Hi everybody, today we're going to continue our talk about optimization and just do some more problems so you get a better feel of how to complete these problems on your own. So the first one I have today is a Las Vegas hotel can fill 2,000 rooms at a price of $150 per night. For each $5 increase in price, they will fill 25 less rooms. Find the price per room the hotel should charge to maximize the revenue. So the first thing I see is we're talking about revenue, and we know that revenue is equal to price times quantity. So if we read back through the problem, we can see the price started at $150 per night, so we're going to put in the $150, and then that said the quantity would start at 2,000. And then this time it says every time we make a $5 increase, we're going to lose 25 rooms. So we're going to let X be the number of price increases. And our price increases are always going to go in increments of 5. So we're going to say from the $150 that we were charging, we're going to make that a higher price. So we're going to add 5x. But then we know when we do that, we will fill 25 less rooms, but that's per price increase. So it's important that the x goes both with the price and with the quantity. Now we can write r as r of x, and that's a function of the price increases. So when we get to this point, we have to decide, do we want to do the product rule or do we want to distribute and multiply this out? Earlier in one of our previous videos, I multiplied it out, distributed everything. So this time, let's try the product rule. So the product rule, remember we do one at a time. So let's take the 150 plus 5x, take the derivative, it's 5. Then I'll keep the 2,000 minus 25x. Then I say plus. I go back to the 150 plus 5x. And I take the derivative of 2,000 minus 25x, which is minus 25. From there, I do have to distribute, so 5 times 2,000 is 10,000. And then I have 5 times negative 25, which is negative 125x. Then I have 150 times negative 25, negative 3,750. And finally, I have 5x times negative 25, which gives me negative 125x. We can gather like terms. So we have the 10,000 and the negative 3,750. That gives me 6,250. And then the negative 125x minus 125x gives me negative 250x. And this is our prime of x. So we have our derivative. We know we want to set that equal to 0. So 6,250 minus 250x equals 0. So 6,250 equals 250x. That tells us x is equal to 25. Now what we didn't do, and maybe this is a little out of order, which is okay, is we didn't look at how many price increases could we have, right? So as we talked about before, we could decide to do no price increases. So when we're looking at our domain, it's going to start at 0 to say we could choose to do nothing. We can be very happy with selling 2,000 rooms a night for $150 each. But we also said we might want to make more money, so we do these price increases. So when I go to figure out the domain, you're back at the revenue function. And the 150 plus 5x, well, we could do that forever. That wouldn't be a problem. You could increase as much as you wanted. But the problem would be that less people are going to come over time. So we want to look at when is 2,000 minus 25x equals 0. What this says is, when have you made so many price increases that people no longer want to come to your hotel? So if we set 2,000 minus 25x equal to 0, it gives us 2,000 is 25x. That says x is equal to 80. So that's the most price increases we can make. That says you've increased the price so much no one's coming, right? So now what do we have? We have this critical number of 25. We have endpoints of the domain 0 and 80. So we want to find the revenue when x is 0, when x is 25, and when x is 80. I'm going to write it here. R of x is equal to, parentheses 150 plus 5x times 2,000 minus 25x. And then I can do r of 0, r of 25, and then also r of 80. So if we make no changes, we're going to have $300,000. If we change the price 25 times, we'll make $378,125. And if we make 80 changes, nobody's coming. So our revenue will be zero. I also graphed this just again so we can get that view of what's happening. So we can see that we started, if we make no changes to the price, we'll have a revenue of $300,000. As we start to make those price increases, our revenue does go up, but then it hits a point where we start to lose money because the price is so high, maybe we have too much competition, that the revenue starts to go down. Here's the window I put in. I originally started it at 0 to 80 because we knew our domain, and I said step it by 10, and then on the y-axis I said go from 0, and I wanted to go higher than the max that we found, so I put $400,000, and then I said step that by 50,000. That way I get a good picture of the revenue. Like before, we should always go back and see what was the original question. It said find the price per room the hotel should charge to maximize the revenue. So remember, this X we found of 25 is the number of price increases. So we want to go back to the 150 plus 5 times 25, which says these rooms are going to be $270 per night. Okay, let's try another example. This time we have a salon orders 15,000 bottles of shampoo a year. The bottles cost $8 a piece to make. The charge to set up production of the shampoo is $1,800 per production. It costs $6 to store a bottle for a year. How many times a year should the company produce the shampoo in order to minimize the total storage and setup cost? All right. So remember, when we're looking at these, X is going to be the number of bottles ordered per shipment. So when we're looking at C of X, we have those two costs to think about. We have production and we have storage. So if we look at production, we know that we are going to want 15,000 altogether. So we're going to have 15,000 over X. This tells us the number of times we're going to order. And then each time we order it, they're $8 a piece. So 8 times how many we buy per shipment, plus the $1,800 for the setup. So this is our ordering cost. We mix that with the storage cost. So it says it costs $6 a piece to store. And remember, we've said we have on average X over 2 in storage at any time during the year. So here's our cost function. Remember, we also want to talk about the domain. Domain says what's the smallest we could order at a time? That would be 1. And the most we could order would be 15,000. So this time we do need to multiply this out. So we have 15,000 over X times 8X. Those 8's cancel. So we have 120,000 plus I have 15,000 times 1,800, which is 27 million. I do have to count the zeros when I put that in my calculator. I think that's a good idea that you count them to make sure you get all of them. Now remember, this X we started with, this is going to be X to the negative 1. 6 times X over 2, that one's nice, that's just 3X. So now that we have the cost function, we can take the derivative. This beginning 120,000, that goes away. The negative comes down, so now I have negative 27 million. X to the negative 2, derivative of 3x is 3. We are going to set that equal to 0. So since we've done this so many times now and I'm thinking equal to 0, I know I'm going to end up with 3 equals 27 million over x squared. We're going to bring the x squared over. We're going to divide by 3. So the x squared came up, it came over here, and then divide by 3. So you can see that here. So we end up with x squared equals 9 million. Take the square root, take the square root. Okay, that says x is 3,000. we looked at 3,000 is in our domain. That was 1 to 15,000. So we're going to find C of 1, C of 3,000, and C of 15,000. So I am going to call this C of x equals 15,000 divided by x times 8x plus 1,800 plus 6 times x divided by 2. So that allows me to look at C of 1, C of 3,000, and C of 15,000. All right, so we can do this comparison. Ordering one at a time, $27,120,003, really expensive. Order 3,000 at a time, we'll spend $138,000. And if we order 15,000 at a time, we spend $166,800, so that we see a savings at ordering 3,000 at a time. So we found out this gave us our min. Back to the question. The question said, how many times a year should the company produce the shampoo in order to minimize the total storage and setup? So we want to know how many times a year. So remember, we want 15,000 altogether. We're ordering 3,000 at a time. So this says 5 shipments per year. So this next one says a barber is trying to determine what price to charge for haircuts. At a price of $20 per haircut, an average of 40 customers come in per day. For every $2 decrease in price, the barber gets 10 more customers a day. What price per haircut should be charged in order to maximize the revenue? All right. So this one, kind of as I go, I think it's good to kind of stop the video, try to write some stuff down, and see if you're understanding the process and what to do. So let's start with saying well, what are we trying to maximize? And it's revenue. So revenue, we know we want to end up with an R of X, and it's going to be price times quantity. So the price started at 20, and with that we got 40 people. And then think about X is going to be the price decreases. So for every $2 decrease, so minus 2x, then we say we get 10 more customers. Important to put the x in both. Then we have to decide, what are we going to do? Are we going to do product roll? We're going to multiply. I'm going to multiply. I do think students like that way better, but I do like to show both. So I'm going to do 20 times 40, that's 800. I'll do 20 times 10x, that's 200x. I have negative 2x times 40, that's minus 80x. And then negative 2x times 10x is minus 20x squared. So we can gather that just a little. This is 800 plus 120x minus 20x squared. From here, go ahead, take your derivative, set it equal to 0, then come back and check, see how you did. So hopefully you got r prime of x, 800 gives me nothing, 120x becomes 120, negative 20x squared becomes negative 40x, you set that equal to 0, 120 is 40x, and x is equal to 3. So we have our critical number. Now I want you to think about, what is your domain? What's the smallest number of price decreases that you can make? What's the largest number of price decreases you can make? Again, stop me, try it on your own, come back and check out how you did. What we should think always is the smallest thing we could do would be nothing. To say don't change the price, we're happy with charging $20 a person. But then this 20 minus 2x, as it's going down, at some point we'll hit 0. So 20 minus 2x equals 0 when 20 is 2x and x is 10. So 10 is the largest number of price decreases we can make at that point. We're doing the haircuts for free. Okay, once you find the domain and you have the critical number, you're going to plug in r of 0, you're going to plug in r of 10, you're going to plug in r of 3. So try that, see what you get. So at 0 price decreases, your revenue is 800 a day. At 10, you're getting nothing because you decreased the price too much. And at 3, you have $980 in revenue. So this would be the maximum. So the question said, what price per haircut should be charged? So we have to remember to plug that back in. This was our price. So this is 3 decreases. So the price is 20 minus 2 times 3. This says we should charge $14 per haircut to maximize the revenue. Here's the last one that we're going to do for this series of videos. You have to fence in 12,000 square feet. If the fencing costs $5 a foot for the front and the back and $2 a foot for the sides, find the dimension that will produce the least cost. What is the cost? So let's assume that this is rectangular. So we're going to have a front, let's call that X, we'll have sides, we'll call that Y. This 12,000 square feet, the square feet tells me that is area. So area XY is going to be equal to 12,000. Then when we're looking at the cost, it's going to cost $5 for the front and the back, and it's going to be $2 on the sides. So when I'm looking at the cost, I have 5 plus 5, that's 10x. I have 2 plus 2, that's 4y. This is what I'm trying to minimize. The big problem I have right now is I have x and y. So we want to go back to the area that was xy equals 12,000, and let's solve for y till we have 12,000 over x. That way I can make a cost function that's only in terms of one variable. So I have 10x plus 4 times 12,000 over x. We can simplify that just a little. This is 10x. 4 times 12,000 is 48,000. And let's go ahead and make that x to the negative 1 because we know the next step is take the derivative. So the derivative of 10x is 10. The negative comes down. I have negative 48,000, x to the negative 2. So what we need to do here is set this equal to 0, see what x is going to be. So I have 10 is 48,000. X to the negative 2, well, we know that really looks like 10 is 48,000 over x squared. The x squared is going to come over, and then I'm going to divide by 10. So I have a lot going on here. But I end up with x squared equals 48, and then 2 zeros because I'm canceling 1 from the 10, so 4,800. I take the square root and it's not going to give me an integer, so I'm going to say let's round this to 2 decimal places, and I get x is 69.28. Now we haven't talked about it yet. The domain. I do not have a closed domain, and that's pretty typical of looking at geometric formulas, that we're not going to have a closed domain because it's really hard to decide what would be the smallest possible length or width that I could have and what would be the largest possible length or width I can have. So unless there's given limiting conditions, we don't really have any. So we have to think of this as just being on the interval 0 to infinity. Even though it seems kind of ridiculous to say infinity, we do know that this has to be positive, like that is a for sure. So anytime that happens where I can't do a closed domain, I want to take the second derivative. So here was the first. I had 10 minus 48,000 x to the negative 2. When I take the second derivative, the negative 2 comes down, so this negative is going to be a positive. I have 96,000 x to the negative 3. Well, this is 96,000 over x cubed. This is so important that I have this positive number on top and I have x cubed on bottom where all of the numbers are positive. So I have positive over positive. So you could pick a particular number, you could put the critical number in, or we could just tell from here that this will always be positive. But just for completion, I will write like 69.28 in to show you. So I have 96,000 over 69.28 cubed. And all I care is this is greater than 0. Concave up says, look, we got a minimum. That's what we wanted, right? So back to the original problem. It says find the dimensions. Okay, so we know x is 69.23. Y is 12,000 over x. which was 69.23. That says 173.33. So our dimensions would be 69.23 feet by 173.33 feet. So I hope the multiple videos helped. I think looking at multiple examples is the way to really get used to this. It's nice to have a little break in between them, but always feel free to come back and watch them again if you just need a little bit more practice.